Welcome to ZoomInData. In this session, we explore DBT incremental models and historical data management, a crucial concept for working with large datasets efficiently. Incremental models allow teams to process only new or updated records, rather than rebuilding entire tables every time. Historical data management ensures that changes over time are captured correctly while maintaining data accuracy and performance. Subscribe to ZoomInData for advanced DBT tutorials, real-time project guidance, and interview preparation. What is an incremental model in DBT? An incremental model is a DBT model that only processes new or updated records instead of rebuilding the entire table. It reduces compute costs and improves execution speed for large datasets. Incremental models are ideal for tables that continuously grow over time. How do incremental models improve performance? They reduce the number of rows processed in each run, allow faster builds by only processing changed data, optimize storage and computing resources by avoiding full rebuilds. How do you define an incremental model in DBT? Use materialized equals incremental in the model configuration. Specify a unique key to identify new or updated records. Optionally, define conditions for updating existing rows. What is the difference between incremental and full refresh models? Incremental models update only new or changed data. Full refresh models rebuild the entire table every time. Incremental models are faster for large tables, while full refresh is useful for backfills or schema changes. How do you handle historical data in DBT? Maintain a timestamp column to track changes over time. Use incremental models to append only new data while preserving historical records. For slowly changing dimensions, implement logic to manage versioned or effective dated records. What is a unique key in incremental models? A unique key identifies each record uniquely within the table. It ensures updates are applied to the correct row. Without a proper unique key, incremental updates may result in duplicate or incorrect data. How can you perform a backfill using incremental models? Use the full refresh flag to rebuild the table for historical data. Incrementally append missing or corrected historical records. Ensure that dependencies and downstream models are aligned with the backfill. What are common use cases for incremental models? Daily or hourly data ingestion pipelines. Slowly changing dimensions in data warehouses. Large fact tables where full rebuilds are expensive. Data aggregation and transformation of streaming data. How do you prevent duplicates in incremental models? Use a unique key to identify records. Apply filters or conditions to include only new or changed records. Test incremental logic with sample datasets before deploying to production. How can DBT handle updated records in incremental models? Use the is_incremental Ginger function to differentiate between first run and subsequent runs. Apply conditional logic to update rows where changes are detected. Combine incremental logic with a unique key to avoid data inconsistencies. How does DBT detect changed data for incremental models? By comparing new data with existing data using a unique key or timestamp. Only rows that meet the update condition are inserted or updated. This ensures minimal processing and preserves performance. How do you test incremental models? Run the model on a small sample dataset first. Validate that only new or updated records are processed. Check for duplicates or missing records to ensure correctness. What is the is_incremental function in DBT? A ginger function used inside incremental models helps differentiate between full table builds and incremental runs. Allows conditional logic for insert or update operations during incremental runs. How do incremental models interact with downstream models? Downstream models automatically reflect incremental changes if dependencies are properly defined using ref. Improper dependency management may cause missing or incorrect data in dependent models. Testing and validation are crucial for maintaining consistency. How do you manage schema changes in incremental models? Use full refresh when altering the schema to rebuild the table. Update incremental logic to accommodate new columns or modified data types. Ensure downstream dependencies are updated to reflect schema changes. How do incremental models reduce data warehouse costs? Avoid processing entire large tables repeatedly. Minimize storage and computation costs by handling only changed data. Efficiently schedule jobs to reduce idle compute time. What are best practices for incremental models in DBT? Always define a unique key. Track updated timestamps for incremental processing. Validate incremental logic in a test environment. Monitor runs and failures for early detection of errors. Can incremental models handle deletes? By default, incremental models handle inserts and updates, not deletes. To manage deletes, implement custom logic or use snapshot tables. Snapshots track historical changes, including deletions, efficiently. How do snapshots complement incremental models? Snapshots maintain historical versions of a table, capture changes over time, including updates and deletions. Work alongside incremental models to provide a full history of data changes. How do you handle large fact tables incrementally? Partition tables by date or another logical key. Apply incremental logic on partitions to reduce processing time. Schedule incremental builds frequently to keep data up to date. What challenges exist with incremental models? Handling schema changes or missing unique keys. Ensuring downstream models reflect incremental updates accurately. Managing large historical data or correcting prior errors efficiently. How do you validate historical data in incremental models? Compare the processed incremental dataset with source data. Check row counts, sums, and key metrics. Implement automated tests in DBT for critical columns and transformations. How does DBT materialization impact incremental models? Incremental materialization is required for incremental processing. Table or view materializations can be used for non-incremental models. Proper materialization ensures consistent behavior across runs. How do incremental models support real-time analytics? By continuously adding new records with minimal processing. Reduces latency for dashboards and reports. Ensures timely and accurate insights without rebuilding entire datasets. When should teams use incremental models over full refresh models? When dealing with large, growing datasets. For frequent updates where full rebuilds are expensive or slow. When historical data is stable and only new records need processing. Thank you for watching. Please subscribe and follow ZoomInData for more advanced DBT tutorials, real-time projects, and interview preparation. For hands-on exercises, practical guidance, or support with real-time DBT projects, contact ZoomInData.